Okay, having seen the SQL model for relations and databases, let's talk a bit about the SQL language now and get into it. SQL contains actually two sublanguages. The first is called the DDL, or the data definition language, and it's used to manipulate schemas, to define schemas, to modify schemas if you, for instance, do want to add or remove columns. These kinds of things are in the DDL. The DML is the data manipulation language, and that's for manipulating the instance, the actual data in the database. It's for querying it, for inserting, deleting, and updating that data. All right? So it's a fairly intuitive language for doing that. A relational database management system, an RDBMS, relational database management system, is responsible for efficiently evaluating the SQL language. So for the declarative statements in the language, the RDBMS is going to choose and run algorithms, and the choice of the algorithm at any given time should not affect the query answer. There may be many ways for the database to implement the query that you type, and all of the ways that it has to implement it should give the same correct answer. Okay, so looking at an example database, this is the database that's in the Ramakrishnan and Gurki book. It represents a boating club. We've got sailors, we've got boats, and we've got reserves, which are reservations of boats by sailors. Okay, and here we have an example instance of the database. So for each of the relations, there's an instance. And you can see that it sort of makes sense if you look at it. We have sailor ID 1 named Fred. He's actually got a boat reserved. It's boat 102. If you go back to the boats table, you can see boat 102 is the Pinta, and it's blue. Okay, so these kinds of facts are being stored in this database. Let's talk about the DDL to create the database. So the first step is to create the sailors table. And here's the syntax: create table, and then the name of the table, followed by a parenthesis, and then a list of the column names and types: SID integer, SName, char 20, which is a 20 wide field of characters, so it's fixed width character field in this case, rating integer, age float. Now you should consult an SQL manual either online or in your book to get the details of all the data types supplied by SQL. They're not exactly the data types that might be in your favorite programming language, but they'll be very similar. Okay, and you can sort of figure out what's the specific types that are provided. Additionally, what we're going to do for this sailors table is we're going to have one more specification in the list. After the list of column names and types, we're going to specify a primary key. And the primary key is actually a list of columns. In this case, it's a list of length 1, SID. The primary key column, or columns, because it is a list, provide a unique lookup key for the relation. So we can think in this case of the sailors table that the SID column is the unique lookup key for sailors. You look them up by SID. As a result, you can't have a duplicate value in the primary key columns. Okay. Note that the primary key column doesn't have to be a single column like this example. It could be two columns, like first name, last name is a kind of easy primary key to think about in some schema, right? So you could say Bob Jones is the key to the students table in a, you could say first name, last name is the key to the students table in a education database, and Bob Jones might be something you'd look up in that students table. Okay, and in that case, of course, you can't have two people named Bob Jones, so that duplicate constraint is on the pair of columns, first name, comma, last name. All right, here's the create table statement for the boats table in our example. Again, it's got 3 columns, each of which has a type, and it's got a primary key, which is, in this case is BID. And then finally, we've got the reserves table, which actually has a primary key, in this case, of 3 columns, SID, comma, BID, comma, day. Now you should ask yourself, as you think about this, why is it 3 columns? What if the reserves table was only on the SID column? What if the reserves table was only on the BID column? What if the reserves table was on SID, BID, but not on day? None of those things would quite make sense, and you should think about why. Now finally, last detail in the SQL DDL for this schema is we're going to talk about foreign keys in the reserves table. You can think of foreign keys as pointers in schemas. So what we're saying is that reserves has a foreign key, SID. So the SID column of reserves is a pointer, it references, to the sailors table. So foreign key SID references sailors means this SID column of reserves points to the sailors table. Sort of like that. What we're saying is that if there's a value in the SID column of reserves, like 1, that's a reference to a value in the SID column of sailors. Now notice that when we said references sailors, we didn't say which column of sailors, by definition, a foreign key references the primary key columns of the table that it references. So in this case, the primary key of sailors is the column SID. And so the reference SID in reserves is to the SID table column of the sailors table. Okay, but if that column had been called sailor ID, then it would have been a pointer to something called sailor ID. The primary key of sailors is the referent. It's the thing we reference when we say references sailors. All right. Similarly, we can have a foreign key that references boats by BID. So BID is a column in reserves that references the primary key of boats.